Hi there, I'm Michael, and I am developing a game. To begin with, let me tell you a little bit about what it is that I'm building, and we'll go from there. Up until now, I have been posting these updates in chat messages to my friends, and I think that's made it a little bit difficult to track how much progress I've actually made, and I think it's also annoying my friends a little bit. So we're going to put all those updates into one video, and we'll release it whenever I think I've hit a good point to do so. That means that these might be a little bit inconsistent, but hopefully it'll mean that they will always be interesting. I'm building a small-scale RPG set in an online persistent world. What that means is that you will be able to go through the game with your friends, and you might make some new ones as well. I want to clarify that this is not an MMO. I don't have the time, the money, or the resources to develop anything on that scale, and I would highly discourage anyone who is thinking about getting into making games from picking up an MMO as their first project either. These are projects that very rarely get finished. I'm developing this game in Rust and using a game engine called Bevy. Now, Bevy is a little bit more of a framework than a typical game engine like Unity or Unreal, and as such you don't have that UI-based interaction for designing your worlds. You have to do practically everything in code, and if you want any tools, you're going to have to build those tools yourself. As such, there is going to be a little bit more code on screen than there otherwise would be in any other devlog. I'm going to have to explain some technical concepts, but I'm going to try and keep this accessible. I'm going to try and make sure that even if you've never touched code in your life, then you can sit down, enjoy these devlogs, and you'll still get something out of it. The other key thing to note is that I'm looking to build all of the assets for this game myself. That means that I'm going to be building the models, the code, the music, the sound effects, and anything else that might go into the game, I'm going to be doing. This is an incomprehensibly stupid decision to make, but I think it will build a more coherent project at the end. I am a software developer in my day job, and even then, not in the programming language of Rust. So we'll see how this goes, but if things have to be reworked over and over again because I learn new things and realize I have to redo them, that's what's going to happen. Okay, so just to begin with, let's talk a little bit about how multiplayer games generally work. So I'm just going to switch over to my iPad here, and there are two ways by which multiplayer generally works in video games. The first is called peer-to-peer, often stylized as P2P. Now the way this works is either all the clients will communicate with one another, or one of the clients will be selected as the host and all the communication will happen with them. It's sort of like that player is acting as a temporary server. This is nice because you don't have to pay server hosting fees. Those players communicate with the host, and then the host game is the one that's treated as the source of truth. So if a person says that they moved here, if the host decides via whatever game logic that they're cheating, it can tell them, no you didn't, right? However, if the host happens to be the cheater, nothing you can do about it. Everyone else just has to deal with that problem. Also, because the host can see the IP addresses of everyone who's connected to them, it is possible for them to, if someone is beating them, decide that they're going to use some nefarious means to shut down that person's internet connection. We're not going to be doing that. We're instead going to be using something called server authoritative gameplay. And what that means is we're going to have our server system, and then all of the clients will connect to it. But the clients themselves won't be running any of the gameplay calculations. They act as what's called dumb terminals, which means that they'll draw the pretty picture on the screen of here's a building and here's a player and here's another player. It will draw that on the screen. But anytime they want to actually perform an action, it's going to send a message to the server, and then the server is going to decide, okay, that's the action you want to do, here's what will happen. And every game tick, it will send a message back saying, here's the new state of the world, which will lead to then that player's now there. Yeah? But they won't actually do any of the gameplay logic on the game client itself. You might question why you would do this, but essentially this gives you a couple of benefits. The first is that you don't have to worry about the various clients having access to the IPs of the other players, as I previously mentioned. And also, the server can continue running even if all of the clients disconnect. Now, that's really useful if you want any sort of time-based mechanic. That can happen even if no one's connected to the game. What I want is for our NPCs to have a life of their own. At certain times, I want them to do certain things. You might have seen that style of multiplayer server if you played a game like Minecraft. That's why we're going with what we're doing. How this actually works, that you need some sort of communication method between the client and the server. Now, if this were a website, we might use something called HTTP, which you'll recognize as the little thing that you have to write before a URL to connect. And that's the method by which most websites are communicated. The issue with HTTP is that it's generally designed for one-way traffic. So the client will say, hey, can I have this website? The server will go, yeah, sure. And send the website, and then it closes the connection. There's no way to continue that conversation. Instead, we're going to focus on two other protocols. The first is TCP, and the other one is UDP. Now, the way UDP works is that the server and the client, they know each other's IPs, and they can send messages over. Really straightforward. There is some complexity about making sure that you know if a server or client is still listening, but the way UDP works is that you don't really care. This is really, really useful if you're making a real-time game. If you're, for instance, moving constantly, then you want to send regular updates of, hey, here's where you are, here's where you are, here's where you are, here's where you are. But you don't actually need to know where they were previously. You might notice that occasionally someone jumps backwards a little bit because of lag. And what's happened is one of the messages has come in possibly after another one, and it didn't really care. It just processed the messages as it got. TCP is a little bit different. The way TCP works is that the messages are organized. So message 1, 2, and 3. Message 1 gets sent to the client, and until the client goes, yep, got that message, and sends an acknowledgement back, message 2 won't be sent. It works in something called streams, which you can just think as constant zeros and ones going back and forth. Unlike UDP, TCP does have a concept of connections, and so after a certain amount of time, you will break that connection and say this person's disconnected. Because this is a point-and-click game, it is 3D, but because it's a point-and-click game, we will be using TCP because we don't need to have particularly fast messages back and forth, and it's generally a little bit easier to implement. I'm going to do myself a favor, do TCP. So my task for today is relatively straightforward. I need to add usernames to the system. So when you join the game, you can put in a username, press connect, and you'll join with that username. Later on, I'll introduce a auth server that will, connect that to a user account. But for now, I just need some method other than here's a random number. Here you go. I need to send that through to the server. So what we're going to do, I'm going to put some music on, mute, and we'll get on with it. So I'm just going to jump in really quickly and explain the bug that I'm currently trying to resolve. The issue is that when those messages come in, they get put in a queue, which we're going to call a buffer. And all this buffer does is, remember at the beginning of the video how we explained that everything was over in zeros and ones as a constant string? The buffer gets those messages, well, not those messages, it gets that stream, and it puts the zeros and ones into the list in single bytes, which is 8 zeros and ones. And it reads the first message that it receives. That's a number 11. And because that's an 11, it knows that the next 11 messages well, the next 10 messages, I should say, because the first one was that one. The next 10 messages are all part of the same instruction from the server. But there's a bug in them, what I'm furiously debugging. It took about 4 or 5 hours. When it got rid of those messages from the buffer, it was keeping its counter of where to start reading from at the number 2. Now this meant that it's not reading this message. It's not even reading this message. It's reading the 3rd message that comes in and trying to get the amount of time ahead of it. No, not the amount of time, the amount of information in the instruction ahead of it. So, in order to fix that, when the messages are processed, rather than trying to do maths, I don't know why I did maths, it takes the queue, it cuts off the length of the message from the beginning of the queue. And previously what it was doing was it was counting this length, this one here, putting it into a value, so we'll call that length, and going, yeah, you know that pointer? Well, we're going to take away the length from it, right? Don't know why this was failing. I don't know why me counting this length was going wrong. I don't know. But simple solution. Rather than doing any sort of maths, we just do pointer equals 0. That was the fix. Okay, so if we launch our game, you can see where we're up to. So when you launch the game, you get a little window which will eventually turn into the login screen, and you can put in a username at the moment. Now that's the new functionality that's been added today. So you can put that in, click the login button, and it'll take you to what will be a loading screen. For now is a blank screen, while it connects you to the server. Spawns you in, and we have our little guy here. We can click around on the map and we'll go to wherever we need to go. If we quickly switch to iTerm here, and let's clear that one. This one here is what's actually going on. So you can see that we clicked on this location, it sent the move message with a coordinate to the server, and then the server each tick sent us back where we needed to move to this frame. So we click again, you can see that it's receiving them, and we've moved over. We can also use the chat. As you can see, it's using that username that we implemented, and it's also in here. If I quickly launch a second version of the client, you can see we've got Dave here. We can see Mike there. Put them next to one another. They can see each other move. We can send a message. It appears on both. We can have them both moving at the same time. So that's working. If you'd like to keep up to date with this project as I develop it further, then feel free to subscribe to the YouTube channel. I'll be posting these updates as and when I've got new functionality to show, and I'm really excited to be doing devlogs for the first time. Obviously, as a developer on the back end mainly, I don't often get a chance to show off what I'm building, and so this is a pretty exciting and new opportunity for me to be going through programming stuff in a way that is actually tangible, and I can show it to people. Aside from that, thank you very much for watching, and I will upload another one of these soon.